I'm very happy to give you a brief introduction on how to live longer using both high-tech and low-tech approaches. Very quickly about myself, my name is Kris Verburgh. I'm a medical doctor by training. I'm a biotech consultant, speaker, partner at an investment fund that invests into new technologies to address aging, and researcher focusing on aging and the future of medicine and biotechnology. I would like to start this presentation with a quote saying that one of the most remarkable discoveries is one that surprisingly few people know about. It's possible to slow aging in lab animals. In fact, it's easy to do so. There's a quote of Professor David Gems, who is a well-known aging researcher, and perhaps we should not be too surprised by a quote like this, because nature went before us. Nature already created animals that seem to be immortal. These are animals like polyps or jellyfish. You have a polyp called Hydra that doesn't seem to age. You have specific jellyfish like Turritopsis dorni that can even rejuvenate themselves, so they can become younger when they are stressed. In humans, it's just the opposite. When we get stressed, we become older, faster, but these jellyfish can do a little bit the opposite. Now, you might think, well, I am not a jellyfish, I am not a polyp, I'm a complex human being. This is very far removed from me. That's correct. But also in your own body, there are cells that can be immortal, only you don't want to have these cells. These are called cancer cells. Cancer cells are cells that are immortal in the sense that they can keep dividing after every division, they stay young after every division. There are cancer cell lines in labs that have been dividing for decades and still are as equally vigorous as decades ago. And then there are also babies. Have you ever wondered why babies are born young? That's very remarkable because babies are born from a mother who is, for example, 30 years old. The baby itself is not as old as the mother, it's not 30 years old, it's 0 years old. So what in fact happens in the mother, the egg cell is 30 years old. When the egg cell is fertilized by a sperm cell, the 30-year-old egg cell reprograms itself to 0 years, so that the baby born from that fertilized, reprogrammed egg cell is 0 years old and not as old as the mother. So these are some examples showing that it's possible to slow down aging, even partially reverse it. Nature have been doing it already for millions and millions of years. So you can ask yourself the question, can we use these insights to also address aging for our own bodies, happening inside our own bodies? So how can we live longer? Well, there are two main approaches. The high-tech approach, which involves technologies like gene editing, gene therapy, epigenetic therapies, transcriptomic drugs, mitochondrial rejuvenation, lysosomal therapies, cellular therapies, and so on. And then you have the low-tech approach. The low-tech approach is often underestimated, but it's still very important. These are things like nutrition, food supplements, other lifestyle factors like exercise, sleep, stress, and health tech, using wearables to monitor your health and to act on your health. So let's first go into high-tech approach, then low-tech approaches. But first, before we dive into these approaches, let us ask the question, why in fact do we age? Because we need to figure out why we age so we can develop technologies to act on these aging mechanisms. Now, there are many reasons why we age. These are a few examples. And luckily, scientists boiled down these examples to 9 important reasons or mechanisms why we age. These are called the hallmarks of aging. Now, this is a very famous model, but it's not complete in the sense that besides the 9 hallmarks in this model, there are some other hallmarks that are not incorporated, like cross-linking, for example. But these 9 hallmarks of aging are a good starting point. And the hallmarks described in this model are the following. One reason why we age is genomic instability. Another is telomere attrition, epigenetic alterations or changes is a third reason or hallmark why we age. Loss of proteostasis, deregulated nutrient sensing, mitochondrial dysfunction, cellular senescence, stem cell exhaustion, and finally altered intercellular communication. So these are 9 mechanisms or reasons why we grow old year and decade after decade. Now we can ask ourselves the question, can we act on these hallmarks? Yes, we can, using new biotechnologies and also lifestyle factors. So let's first go into high-tech approaches to address longevity and look at cutting-edge biotech to impact these hallmarks or partially reverse them. Now let's first start with epigenetic alterations. There are all kinds of new technologies in development to address this hallmark of aging. One example is through reprogramming the epigenome. Now, first, quick explanation of what's the epigenome. The epigenome is the intricate molecular machinery that surrounds the DNA and that determines which genes are switched on or off. So, for example, you have a liver cell. In the liver cell, only the liver genes are switched on. The stomach genes, the brain genes are switched off in the liver cell. In the brain, luckily, only the brain genes are switched on and not the stomach genes that create hyperchloric acid and so on, or other acids. So in that sense, it's very good that the epigenome regulates the phenotype and the functioning, the proper functioning of the cells, also their lifespan. It's all regulated through these epigenetic modifications. So the epigenome is very important, and when we get older, the epigenome is more and more deregulated. So it means some genes are switched on that should be switched off, like cancer genes, and the opposite is also true. So sometimes genes are switched off that should be switched on, like cell protective or repair genes. So when we get older, the epigenome becomes more and more deregulated. How can we fix this? Well, there are many methods. One way is through partially or cyclically upregulating Yamanaka factors. The Yamanaka factors are in fact small proteins that epigenetically reprogram cells. Scientists found out if they upregulate these Yamanaka factors cyclically in the cells of mice, they could rejuvenate these mice. So these mice, they became more active, they lived longer, they could regenerate specific organs better. You can see with your own eyes. Here you see two sections of muscle biopsies. On your left, you see a normal old mouse. You can see that the muscle cells have shrunken due to aging. There is deposit of fibrous tissue and so on. And then you see on the right a rejuvenated mouse, so the same mouse that got this epigenetic reprogramming done. And you can see it with your own eyes. You don't have to be an experienced pathobiologist to interpret these biopsies. You can clearly see that the muscle cells are much bigger, they are plump again. It's much less deposit of fibrous tissue and so on. So these kind of studies are very important. They show that aging is a process that cannot just be slowed down, but actually be reversed. So it would be a bit equivalent of having an 80-year-old human that becomes 50 years again, of which the age is rejuvenated. Now, this epigenetic reprogram is very powerful because it can reset multiple other hallmarks of aging. So it can reset telomere size, mitochondrial metabolism, oxidative stress levels, and so on. So not all hallmarks of aging are equally important. Some hallmarks could be more important, and perhaps one of these hallmarks is the epigenetic reprogramming aspect, or fixing the dysregulated epigenome. There are many other studies. For example, in this study conducted at Harvard University, scientists could help nerves to regenerate themselves much better. As you can see in the image above, there is a nerve, it's damaged, and then you see an image in the image below in a mouse that received the epigenetic reprogramming, the Yamanaka factors, some of them that were administered, they enabled this damaged nerve to regenerate much better. So interestingly, these Yamanaka factors can reset aging, can improve regeneration, and so on. Now, another hallmark of aging that needs to be fixed is altered intercellular communication. So what happens during aging is that cells start to communicate with each other in a different way. They start to secrete substances that damage healthy cells. In fact, these are, for example, pro-inflammatory substances. Cells secrete them, they start to circulate in the bloodstream, and they damage the stem cells or hinder the functioning of the stem cells. And in fact, when we get older, our cells start to bathe in a age-systemic milieu that consists of all kinds of substances, pro-inflammatory and other substances that damage healthy cells. How to fix this? Well, some insights on how to approach this came from an experiment called heterochronic parabiosis. In this experiment, it's a bit gruesome, but mice were shown together so that an old mouse shares the same blood circulatory system with a young mouse. So the blood from the old mouse streams through the vessels of the young mouse and vice versa. So this changes one mutual blood circulatory system. And scientists found out that the old mouse exposed to the blood of the young mouse got rejuvenated a little bit, in the sense that the tissues could regenerate better in the old mouse. Unfortunately, the young mouse aged a little bit faster, so that's a bit of a bummer, but it's interesting in the sense that these experiments showed that there are specific substances in the blood of young mouse that have a rejuvenating effect, and that there are specific substances in the blood of old mice or old animals that can accelerate aging. So this is a bit of a similar experiment in which human umbilical cord plasma was administered to old mice. Human umbilical cord plasma, or this component of blood, is of course very young. This is almost as young as it can get. And these old mice receiving that young blood, they had all kinds of symptoms that improved. So they could regenerate their organs better, they were more active, they had protection of cognitive deterioration and improvement and reversal of specific cognitive deterioration parameters and so on. So these studies show, in fact, that there are specific regenerating substances in the blood that could perhaps in the future be administered together in a cocktail. But what's more important is that these studies again also show that aging is not set in stone and that it's a partially reversible process, just as we saw with epigenetic studies. Another hallmark of aging that needs to be addressed is cellular senescence. So when we get older, everywhere in our bodies, senescent cells arise. So these are damaged cells that refuse to die, they stick around, and they secrete substances that damage the healthy surrounding cells. For example, in our skin, when there are a lot of senescent cells in our skin, the senescent cells will secrete substances that damage the skin stem cells and the healthy skin cells, contributing to looking old, wrinkle formation, sagging skin, thinning skin, and so on. In the blood vessel walls, when there are a lot of senescent cells, they will damage the blood vessel wall so that we get hypertension, atherosclerosis, and so on. These are a few examples on how senescent cells start to mess up our body slowly but steadily when we get older. More and more senescent cells arise everywhere. So we need ways to remove these senescent cells or to reprogram them. And one way has been achieved in this study in which senescent cells were destroyed in old mice. On the picture on the left, you can see at the top an old mouse with a gray fur, osteoporotic back, not very active, the mouse again. And then you see the same mouse that got rejuvenated by the clearance of its senescent cells. And you can see in the picture below that the same mouse, the gray fur became shiny black again, the osteoporotic back improved, the mouse was much more active, and so on. On the right, you can see an older image, you see two mice of the same age, and you can see the mouse at the top, it looks old, and the mouse at the bottom, it looks much younger, so it has a shiny fur, and it's much more active, and its organs and tissues look better, can regenerate better, and so on. So this study again shows that aging is a partially reversible process. Another hallmark of aging, or other technology to address hallmarks of aging, is gene editing or gene therapy. And this technology has the potential to reprogram all kinds or address all kinds of hallmarks of aging. Now, gene editing is one example of these new technologies like CRISPR-Cas9. This technology is quite recently discovered, so it's a fascinating new development. All kinds of scientists are very enthusiastic about these new gene editing tools that will enable them to much faster and much more accurately, much cheaper modify or rewrite genes. So you can look at these gene editing tools as small molecular scissors that can cut out, rewrite, replace specific genes. Now, gene therapy, gene editing, it has been approached often in a very classic way, in the sense that there were scans done, sequencing of the human genome of very old people in the hope that they had specific genes that protected them against dying and aging. But that was not very fruitful, that approach. So apparently very long people, centenarians, these are people who are 100 years or older, their genomes have been sequenced and they didn't have very noticeable genes that protected them against aging. So it was a bit of a disappointment. What we saw is that hundreds of different genes are involved in aging. All of them contribute a very tiny little bit to the rate of aging, but there are no very really protective genes that substantially slow down aging, unfortunately. So we need new approaches, more promising approaches So what we can do for gene therapy and gene editing to slow down aging is using combinations of genes. So instead of focusing on one gene, you introduce multiple genes into the body and they have synergistic effects. Another approach is introducing multiple copies of the same gene to have a much stronger effect. A third approach is looking for exceptional genes. So these are genes that occur very rarely in the population, but these people that have that mutation, they seem to be much better protected against heart disease or other aging-related diseases. I will briefly give an example of each of these three approaches, starting with combinations of genes. So this is a study showing that you've combined two genes, that you have a much stronger synergistic effect instead of just using one gene. So in this study, specific growth factors and that TGF-beta 2 receptors and so on were used. The genes encoding for these proteins were introduced into cells, and they saw a much stronger effect in improving cardiovascular disease or kidney diseases by using combinations of these genes instead of using only one gene separately. And these are some examples of other genes that could be targeted, could be introduced, or of which activity could be increased to slow down or impact aging. So your genes enabling exceptional endurance, stronger bones, more muscle mass, improved learning and neurogenesis, anti-cancer genes. And there are companies focusing on using gene therapy or gene editing to introduce all these new gene capabilities into humans. One example is, for example, Rejuvenate Bio. Then adding multiple copies of the same gene could be interesting. An example is P53. So very big animals like elephants or whales, they seem to be very well protected against cancer. It's very remarkable because big animals have more cells and one cell is enough to mutate and to devolve into cancer. So if you're an elephant, you have a lot of cells, much more than humans. So statistically speaking, you would have more risk of one of these cells becoming cancers. But that's not what is happening. So these big elephants or whales, some whales can live up to 200 years and they don't get cancer. So at least not when they are 100 or 150 years. So that's very remarkable. It's called Peto's paradox. Now, how can they protect themselves against cancer? One way is by having multiple copies of specific cancer protective genes in their cells. So P53 is an example of that. P53 is a gene that encodes an alarm protein that's switched on when a cell becomes damaged, or when the DNA of a cell becomes too damaged, and then it repairs the damage or it kills the mutated cells before they can become cancerous. So having multiple copies could be interesting. Perhaps we will go to a future where people get multiple copies introduced into their cells to better protect them against cancer. And then finally, there are specific mutations in the population that confer a lot of protection against aging-related diseases. An example is the PCSK9 gene. And we see that people with mutations in the gene have 80% less risk of getting a heart attack. So what we could do is use, for example, gene editing to introduce that mutation into our own cells to much better protect us against cancer, as heart disease or other aging-related diseases like cancer, Alzheimer's disease, and so on. So what these studies show, in fact, is that aging is a somewhat plastic process that can be manipulated. And perhaps we will go to a future where we could live for centuries, because it's not anymore about slowing down aging, it's about more and more reversing the aging process. And if you reverse aging, you can achieve much higher lifespans because you will just turn back the clock time after time. And we are living at very fascinating times, because we see the advent in recent years of all kinds of new fascinating technologies that will finally enable scientists to tweak, to reprogram the cells. And there are a lot of companies also capitalizing on these new technologies. You can see here a few examples of companies that want to address aging itself instead of focusing on the aging-related diseases. So very interesting. Now, we talked about some high-tech approaches to address aging. There are, of course, low-tech approaches to live longer. Many of these approaches are already available today. First example are prescription drugs to live longer. So there are some drugs that are targeted or that are being researched because they can potentially increase lifespan. These are some examples of these drugs. Most well known are metformin and rapamycin. They are currently under investigation to see whether they can extend lifespan in humans, but we have to be careful because these drugs, they have side effects, and we have to be very careful. And also, it's not because they extend lifespan in mice that they will do it in humans. So, but these are some potential candidates that could slow down aging. Now, besides drugs, there is of course nutrition. Nutrition is very important to impact aging. It's often underestimated, but the best technology we currently have to live longer is the food we eat. And it's tremendously important to impact aging. There are thousands of studies showing that what we eat, how we eat, when we eat, slows down the rate or accelerates the rate of aging, depending whether it's healthy or unhealthy food. To give you one example on how nutrition impacts aging, let's go to this slide. One example is nutrient sensing pathways. So there are many ways that nutrition can impact aging. It happens through epigenetic reprogramming of the microbiome, but also through the means of nutrient sensing pathways. So this is one example of how nutrition impacts aging. Nutrient sensing pathways, in fact, are activated by nutrients like carbohydrates and amino acids. They will mainly activate insulin receptors and insulin-like growth factor receptors, EGF receptors. Mainly sugars will do that, carbs. And then mTOR is also a very important nutrient sensing pathway or aging switch. It's mainly activated by amino acids. So if you eat in the evening a big steak, the protein in the big steak will be converted into amino acids that enter the bloodstream, and they will mainly activate mTOR. And if you eat a lot of sugars, and starchy foods, you will mainly activate insulin EGF pathways. So these receptors, the insulin EGF receptor is a protein that can be found on the membrane of cells. It's activated by insulin, and insulin is released as a response to carb consumption. And then you see that the mTOR protein is more an intracellular protein. It's mainly activated by amino acids, also by glucose. And if it's activated, then it will spur on cell growth and metabolism, but also aging. And the more cell growth and the faster your metabolism functions, the faster you age. And we have seen in many studies that you can extend the lifespan of many species, sometimes sixfold, like in C. elegans, or double the lifespan in mice by tweaking these nutrient sensing pathways, mostly in such a way that these pathways become more numb to the nutrients, so that the body thinks there are less nutrients like amino acids or sugars circulating. And what in fact stimulates these insulin, EGF, and mTOR aging switches? Of course, as you already could have guessed, a surplus of carbohydrates, not just sugars, but also starches. People think of carbs or reducing carbs, they may not think of reducing intake of soda or sugary foods like sweets and cake and so on. But of course also starchy foods like bread, potatoes, pasta, rice, they are made up of starch, and starch is made up of glucose chains of glucose. So in that sense, if you eat bread, potatoes, pasta, rice, you will still consume a lot of glucose molecules. They will end up in the bloodstream and cause high and often very protected levels of glucose in the bloodstream. And animal proteins are other important stimulators of these aging switches. And we see in many studies, in thousands of studies, the importance of nutrition on aging and aging-related diseases. These are a few examples. People who eat food with a high glycemic index and load, which means it's food that causes high sugar peaks and protracted sugar peaks in the blood. These kinds of foods, they increase your risk of heart disease. We see that they increase your risk of diabetes. And we see, in fact, that the best diets that are around are low glycemic index and low glycemic load diets. So these are diets that don't cause high and protracted sugar peaks in your blood. There are many other studies showing the power of nutrition on our health. So this is the Lion Diet Heart Study. It divided people in two groups. The first group followed the low-fat diet of the American Heart Association. Second group followed the more unofficial Mediterranean, more fatty, rich diet containing olive oil, white meat, nuts, fatty fish, fruits, and so on. And the result is, in fact, that the second group, group 2, did much better. We saw about 70% less mortality during the few years that this study lasted in the group that followed the unofficial, more fat-rich diet compared to the official low-fat American Heart Association diet. So this study shows two important things. It shows the power of nutrition. People following the more unofficial fat-based diet lived or had much more chance of not having a heart attack compared to the control group. And the second thing that's also very important, it shows that a lot of these health recommendations, these official health guidelines that many countries or institutes issue can be much better. And so that's something that aggravates me as a medical doctor, is to see all these guidelines to treat type 2 diabetes or heart disease. They are not really that effective because they can be much, much better. And they are very watered down, oversimplified, and so on. But it's a whole story on itself. Not going into it why these guidelines can be much better. But this is one of the many studies showing that these official guidelines can be improved upon. Now, we don't need these kind of scientific experiments to see the power of nutrition on our health. And there are also natural experiments that show the tremendous impact of nutrition on our well-being and health. Take, for example, the Pima Indians. They live in the south of the US. Before they came into contact with the West, they lived very healthy. They had a very healthy diet. And as you can see on the picture, overweight or obesity was very rare. Same for type 2 diabetes, cancer, heart disease. It was many-fold lower than is currently the case. And these Indians came into contact with Westerners. They start to eat a more Western diet with a lot of starches, sugars, unhealthy fats, a lot of animal protein. And now we see that about 60% of adult Pima Indians have type 2 diabetes. We see a 90-fold increase in diabetes, overweight, and so on. There are many similar studies showing what happens when indigenous populations that followed a healthy diet come into contact with the West, start to eat a Western food pattern, and you see a huge increase in not just aging-related diseases, but also in acne, diseases like gastric acid reflux, back pain, depression, malocclusion of the teeth, and so on. So it's not just about aging. A lot of other diseases are also caused by this unhealthy Western food pattern and lifestyle in general. There are also studies that are a bit opposite, so they show what you can achieve if you eat or live healthy. And this study was conducted with 120,000 participants, and it found that if people just paid attention to 4 simple things, they had a healthy food pattern, they were not overweight, they did regular exercise, and they didn't smoke, that people doing these 4 simple things lived much longer than people doing not any of these things. So the result was that, in fact, men lived on average 8.5 years longer, as it was calculated, and women could live for 15 years longer. That's considerable because it's not just about, for example, to live 15 years longer. People who adhere to such a more healthy lifestyle will be also much longer not sick. They will not be plagued by aging-related diseases for a much longer time. So they would not only just live 15 years longer, they would perhaps have 20 years later, they will see the advent of all kinds of aging-related complaints. So a lot of people, if they eat unhealthy, they get type 2 diabetes or pre-diabetes when they are in their 50s. They get increased cholesterol, LDL, HDL levels, and so on. They start to get hypertension when they are in their 50s. But if you eat healthy, you will start to get all these things when you're in your 70s, or perhaps even if you're in your 80s. So these are one of the many studies showing the impact of nutrition. You also have a lot of studies conducted regarding the longevity zones. So these are areas in the world where people live much longer, and they seem to be also much healthier when they are old. Examples of these zones are in Okinawa or Sardinia. And scientists, they went to these zones to find out what makes these people live so much longer and healthier, and they describe some common characteristics of these longevity zones. One characteristic is that they follow mainly plant-based diets. It consists mostly of vegetables. Secondly, they consume little meat. If they do eat animal protein, it's often fish, which is very healthy because of the omega-3 fatty acids, furanic acids, and so on. They often consume healthy fats. including olives, olive oil, nuts and seeds and so on, also coconut. There is a bit of discussion because coconut contains saturated fats, and some people are saying, well, saturated fats are not healthy. A lot of governments advise against saturated fats, but it's not that simple because short-chain saturated fats like butyric acid are very healthy. So it's not that all saturated fats are healthy. On the other hand, you have a lot of health gurus saying, well, saturated fats are healthy no matter what kind of saturated fat. It's also not that simple because some saturated fats can be unhealthy, especially the long-chain ones. So in conclusion, you have some saturated fats that can be healthy, some can be neutral, some can be unhealthy. But anyway, we can go another time more into depth, but we see that these people eat a lot of healthy fats. Another thing is we see that they consume little carbohydrates, they eat a lot of spices, they have this 80% rule, which means that they eat until they are 80% full, not completely satiated, as a lot of people do in the West. And we also see that these people often pay attention to tranquility. So they have moments of siesta, of meditation, they have a lot of social contacts, they do not smoke, they drink alcohol in moderation, they have natural exercise, they have goals in life, and so on. So what exactly would entail a healthy longevity diet? We can summarize that in 6 simple rules, in fact. So there is a lot of conflicting dietary advice, but the problem with a lot of dietary advice is that it doesn't take into account the long term. So a lot of studies show healthy effects on the short term, a few weeks, months or years, but what if you follow it for many years? So we need better approaches to really assess which diet is healthy. And I think if you approach food and nutrition from the aging viewpoint, that's much more interesting to see whether a diet or food pattern is healthy in the long term, because if you know why we age, you can better, in fact, figure out whether a specific food pattern has some beneficial impacts on the long term. So in summary, first of all, a healthy longevity diet entails much less bread, potatoes, pasta and rice. These are starchy foods. Starch is made of glucose. They still cause high glucose peaks, which also accelerates aging through all kinds of different mechanisms. So replace these foods more with vegetables, legumes and mushrooms. So instead of potatoes, pasta and rice, eat more vegetables, legumes, mushrooms. To go more in detail, in fact, vegetables should be the basis of our food pattern, and complement it with legumes, mushrooms, fruits, quinoa and so on. So for example, instead of potato mash, eat broccoli mash. Instead of pasta, eat beans. Instead of rice, eat mushrooms. Thirdly, substitute as much as possible red meat with white meat, like poultry. White meat examples are fish or turkey, turkey or chicken. Eat fatty fish like salmon, mackerel, herring, and so on, tofu, corn, which are meat substitutes. Then no milk, because milk accelerates aging via a myriad of different ways. I can talk for hours about milk and aging, but suffice to say that milk has been created by nature to make animals grow very fast, to make calves grow fast, and therefore milk stimulates all kinds of growth pathways, including the insulin-like growth factor pathway, insulin pathways, mTOR pathways, and so on. We are, as humans, the only species on this planet that keeps drinking milk from another species as adults, and probably the long-term effects are that this product can accelerate aging. Of course, there are a lot of studies showing beneficial effects of milk. Often these studies are short-term, so a few months or years the most. So they are not trying to figure out what happens if you do it for 30 or 50 years. And another problem is that a lot of these studies are directly and indirectly sponsored by the dairy industry. So that's a bit also an obnoxious confounding factor. So should not be underestimated the impact of food industry on scientific studies, of course. Replace the milk, the animal milk, more with vegetable milk, like hazelnut milk or almond milk. Make sure it's the low sugar variants. Then regarding drinking, so don't drink soda because they are full of sugar. They also contain artificial sweeteners. So if you have the low calorie variants, but they can also reprogram the microbiome and increase insulin sensitivity in specific people. There are a lot of good studies about that. But so don't drink soda drinks, and be mindful about store-bought fruit juices because they are full of sugar, of course. So mostly drink water. Drink green tea, white tea, coffee. If you go on the internet, you see a lot of bad stuff about coffee, but if you look at the big picture, you see that coffee has much more advantages than disadvantages. So coffee is protective against Alzheimer's disease, against Parkinson's disease, or cardiovascular disease, type 2 diabetes. So much more advantages than disadvantages. You can drink a smoothie per day, keep it to one smoothie, preferably with low glycemic index fruits like blueberries, and combined with vegetables, which are very low in sugar. Some people say, well, smoothies, bad, because they contain sugar, but it's not that easy, because we see also in studies that people drinking a smoothie made of blueberry fruit, that despite the sugar, they can improve insulin sensitivity, they can even lose weight, they reduce the risk of cognitive decline. So despite the sugar, specific smoothies still contain all kinds of substances like flavonoids, especially in the blueberry smoothies, that can have beneficial effects. And finally, we need to consume more healthy fats. So these are fats from olive oil, olives, walnuts, especially chia seed, fatty fish, avocado, and so on. Then a brief word about food supplements and longevity. Okay, so the problem with most food supplements is that they don't really extend lifespan. So you have a lot of anti-aging food supplements on the market, but they are in fact based, or they contain outdated substances that have shown in well-conducted long-term scientific studies not to extend lifespan. Examples are vitamins, minerals, omega-3 fatty acids, and so on. Of course, if you are deficient in these vitamins and minerals and omega-3 fatty acids, you need to take them, because it's very important to get rid of these deficiencies. But taking extra vitamins, minerals, omega-3 fatty acids to extend lifespan, to slow down aging, unfortunately, it doesn't work. A lot of anti-aging supplements are also based on outdated theories regarding aging. So a lot of these supplements contain antioxidants in the belief that antioxidants neutralize free radicals, which are oxidative substances that damage our tissues. But as we have seen in the beginning of this presentation, we don't just age because of oxidative damage. We age because of many other reasons. For example, epigenetic dysregulation, mitochondrial dysfunction, telomere shortening, protein accumulation. So aging is much more complex than just oxidative damage. And we see, in fact, in some studies that increasing oxidation or administering free radicals that cause oxidation to animals can actually extend their lifespan. And then a lot of these anti-aging supplements might even shorten lifespan, because we see in studies in humans that, for example, some antioxidants can in fact increase mortality risk. So this is an example of many studies showing that antioxidants don't really slow down aging. So these are studies conducted in sometimes hundreds of thousands of participants, and what was found was that antioxidants don't really slow down aging. In fact, it could accelerate aging in some cases, because if you take antioxidants, the cells will sense that there are antioxidants, so they will lower their own antioxidant protein production, because they think, well, there are enough antioxidants around, so I don't have to create antioxidant enzymes. But these antioxidant enzymes are often thousands of times more powerful in neutralizing antioxidants and so on than antioxidants you take orally through food supplements. Also, if you take a lot of antioxidants, cells will perhaps lower their guards and will repair themselves less well, and so on. So this is one explanation on how antioxidants could actually accelerate aging instead of slowing it down. Another problem with most food supplements is that they are even inadequate for basic healthy longevity, because there are a lot of shortcomings with food supplements. Take, for example, the classic vitamin or mineral supplement. Often the doses are way too low, like 50 milligrams of potassium, while ideally you need a few thousand milligrams per day. Another problem is that a lot of supplements contain only one version of a vitamin. Take, for example, vitamin E. There are in nature 8 different forms of vitamin E. So you have alpha tocopherol, beta tocopherol, gamma tocopherol, different tocotrienols. So the problem is, if you take a supplement, it mostly contains only one vitamin type of vitamin E. So it's often called alpha tocopherol. So it doesn't contain beta tocopherol, gamma tocopherol, and so on. And even worse, if you take a lot of vitamin E, which contains only one form or version, alpha tocopherol, then you will inhibit the absorption of the other vitamin versions, because the alpha tocopherol will oversaturate the receptors in the gut to take up the other vitamins. So in the long term, you could have a deficiency of these other beneficial forms of vitamin E. Another example is that a lot of food supplements contain artificial versions of vitamins. For example, take vitamin E. There are some studies hinting that artificial vitamin E is a bit different and behaves a bit different than the natural form of vitamin E. A lot of supplements contain the wrong form of specific vitamins and minerals, like magnesium oxide instead of magnesium malate, which is much better for many reasons, and wrong combinations. So lots of supplements contain, for example, way too much zinc without copper, but zinc inhibits the absorption of copper, so you need both in specific ratios to make sure that you're not incurring a deficiency on the long term. So these were some brief examples showing that a lot of food supplements can be improved. I'm not against food supplements. In my book, The Longevity Code, I spent a whole chapter of the benefits and the drawbacks of food supplements. I think food supplements are very important for your health, but you have to take them in the right way, in the right dose, the right version, the right form, and so on. So we need far better, more science-based, evidence-based food supplements to extend healthy long lifespan. And that's a big problem, because currently there are no real good anti-aging supplements around, and that's unfortunate, because we see in the recent years more and more studies appearing showing some very interesting substances that have a lot of science behind them to impact the aging process. An example of such a substance is alpha-ketoglutarate. So you can see on your left, you see that this substance can extend lifespan in C. elegans worms. On the right, you see some data that can also extend lifespan in more complex organisms like mice. And there are many studies showing indeed that alpha-ketoglutarate can extend lifespan and also improve health span. In this study, you can see that not only these mice lived longer, but they, in their old age, they were plagued by less aging-related symptoms and diseases. AKG or alpha-ketoglutarate could also, for example, improve the health of the fur. So these animals had a more better-looking fur when they were old compared to animals not taking AKG. So this is an example of a supplement that has much more science behind it than, in fact, we see for most other health supplements that are currently are around. Another example is fisetin. So fisetin is a natural ingredient found in strawberries, for example. It can extend lifespan in different lab animals or organisms. It has all kinds of beneficial effects on the body. It can clear senescent cells, reduce inflammation, improve protein homeostasis, upregulate cell protective substances, and so on. And we also see in well-conducted studies that fisetin can extend health span and lifespan. So it can extend not just medium lifespan, but also even maximum lifespan, which is very interesting. And fisetin has some therapeutic activity, and it could yield a potent health benefit in people. So another example of a substance that has much more science behind it is nicotinamide mononucleotide, NMN. So NMN is converted into NAD, and NAD is a very important substance because it is a cofactor of all kinds of enzymes and proteins that in fact reduce inflammation, that improve metabolism, that repair our DNA, that improve the functioning of the epigenome, and so on. Problem is when we get older, NMN levels decline more and more with age. And we see a lot of studies showing that NMN can impact aging in a beneficial way. So these are some examples of studies. And again, we need more substances for food supplements that are more science-based, that have much more science behind them, a bit like this substance. And we see that in fact NMN can have preventative and therapeutic effects and could function as an effective anti-aging intervention in humans. Now, some people will ask the question, is NMN better than NR? Because NR is very touted a lot on the internet, but there are some substances or differences that hint that these substances can be different or from each other, and that probably NMN is better. For example, NMN is one step further down the pathway to create NAD, while NR, it needs to be converted into NM, and then it can be converted into NAD. So NMN is a more direct precursor to NAD. NMN also seems to be more stable in the blood. If you look also at big amalgam of studies conducted around NMN and NR, you see that NMN has more stronger, more extensive effects. At least that's the impression we got from studies, better effects, stronger effects on metabolism, insulin sensitivity, and improving all kinds of aging-related symptoms and diseases. Other examples are studies showing that NMN could improve specific mitochondrial disease like Friedreich's ataxia, while that was not the case in another study with NR. NMN could also improve accumulation of amyloid beta, which is a protein that accumulates in the brain during aging and plays an important role in Alzheimer's disease, while NR couldn't achieve that result. We also see that one of the biggest experts in the world, Professor David Sinclair, takes NMN himself and not NR. Of course, this is not real scientific evidence, but it's interesting to see that one of the world experts in NMN, NR, NAD metabolism prefers to take NMN and not NR. We also see that a lot of startups and companies are focusing on NMN and NMN derivatives to address aging or reduce aging-related symptoms or mitigate them. So that's also interesting. We also know that NMN can be taken orally because there's still a lot of contradicting things circulating or news circulating on the internet saying that NMN is not well orally bioavailable, but that's not really the case. So in studies, if you give NMN orally to mice or to other animals, it's absorbed, and these animals, they have all kinds of biomarkers, aging biomarkers that are improved. And perhaps a final thing, NR is touted a lot on the internet. One reason for the popularity of NR is that it's a patented molecule. More precisely, the production process of NR is patented, so you have specific companies that have these patents or that have licensed these patents that are touting NR a lot and promoting it a lot, while NMN is not patented. So in that sense, that's perhaps one reason why you hear less about NMN and why sometimes NMN is even downplayed. Another reason is also that NMN, until very recently, was prohibitively expensive to manufacture. Quite recently, the price has come down a lot, but still it's very expensive to manufacture, very difficult to manufacture. So that's also a reason why NMN has not been researched as long as NR, and is also was used less in research because it was so expensive. So we in fact need a more science-based, evidence-based anti-aging supplement. And I think it's possible. So we created, in fact, a company called Novos. And Novos is a supplement that wants to slow down the aging process using 12 science-based ingredients to slow down the aging. Some of the ingredients we discussed, like alpha-ketoglutarate and NMN and so on, because we created this company out of frustration that there are so little science-based anti-aging supplements around. So we believe that the time is right now. There is enough science and enough scientific evidence and studies identifying all kinds of natural substances that are very interesting to address aging. So you can subscribe to the newsletter using the email address provided in this slide if you want to stay updated. The primary competitor of a company like Novos or another anti-aging supplement company would be Elysium. Elysium contains two ingredients, NR and pterostilbene. And we find this a little bit disappointing because if you really want to impact aging, you need much more ingredients because NR and pterostilbene, they mainly focus on the NAD, sirtuin, epigenetic pathway, but we have seen there are many other mechanisms of aging like mitochondrial dysfunction, protein homeostasis, telomere attrition, senescent cells, and so on. So therefore, you need a supplement that contains much more ingredients that can impact also the other pathways much more substantially. So therefore, we created a supplement containing 12 ingredients because that way you can target all 9 mechanisms of aging much better. So in our personal opinion, Elysium in fact could be much more improved upon. So in conclusion, in fact, we can say that both high-tech and low-tech approaches will enable longer, healthier lifespans. So we are at a very interesting moment in history. We see the rise of all these new biotechnologies that will finally enable doctors to interact with the cell, to change the functioning of the cells, to reprogram the cells even in a younger state. And we have seen in this presentation that aging science is not just anymore about slowing down aging, but actually about reversing the aging process. Nutrition is arguably the most important low-tech intervention we have to achieve maximal lifespan. Nutrition is often underestimated. I do not agree with it. I think nutrition is very important, and it's also is going to stay important. And nutrition and lifestyle in general will always stay important, even in the future with these cutting-edge, high-tech longevity therapies. Because some people will say, well, I can keep eating unhealthy because in the near future I will have this biotech to rejuvenate myself. But I would not really count that much on it, or at least on that approach, because first of all, you have to live healthy and attain a healthy lifestyle to stay around long enough so you can profit from these new biotechnologies to come about, because it will take many decades for these new technologies to come to light, to be approved, and so on. And secondly, even if these new technologies are around, you want to still attain a healthy lifestyle, because that will postpone your need for these treatments. Also, if you eat healthy, you have a much more productive life. If you eat unhealthy foods, you eat a meal with a lot of carbs and animal protein. After the meal, you will be tired, you will enter a food coma, you will feel much less productive compared to people eating healthy. They sleep better, they have more motivation, they have more energy. So you have also immediate benefits when eating or attaining to a healthy food pattern. And in this presentation, we quickly delineated what such a healthy longevity food pattern would entail. And finally, companies addressing both high-tech and low-tech approaches to longevity from a strong scientific foundation will tap into the biggest industry in the future, is the health and longevity industry. Because everyone wants to stay healthy, everyone wants to live as long as possible and stay productive as long as possible. So the longevity industry or biotech industry and lifestyle industry will be the biggest industry in the future. And I hope in this brief presentation I was able to give you a first glimpse in how we can achieve that future using both biotech and lifestyle interventions to enable a long and healthy life. Thank you very much for your attention. And if you want to learn more about these approaches, I have written a book. It's called The Longevity Code. It goes more into depth also about these new technologies, but also about lifestyle, especially nutrition, and what we can eat to live a longer, healthier life. So again, thank you very much for your attention.